Hey, geometry. Let's talk about dilations as transformations. We're going to do a tad bit of review, first off, to talk about how we discuss transformations. So we're stretching back to Unit 1. First of all, what does a transformation of the plane mean? I know this term has always confused us a little bit, a transformation of the plane, so I thought I'd review it a little bit. Transformation of the plane is a rule that assigns each point in the plane to a unique point, to a unique letter. We use function notation to denote transformations. That is F. F denotes the transformation of a point P and is written as F of P. So a transformation moves point P to a unique point. So we say that F of P gets moved to P prime. Okay? F of P is called the image of P, or P prime. So remember that every point P prime in the plane is an image of some point P. So F of P equals P prime. If we just translate it, let's say we translate it to array AB. So we're going to say F of P, translated about the same amount, I don't have a compass, is P prime. That's not too bad. That looks a little bit bigger, but also, implied properties of rigid transformations. Rigid motions map a line to a line, array to array, a segment to a segment, and an angle to an angle. Rigid motions don't change the properties of the item, the line, the array, the segment, the angle. Rigid motions preserve lengths of segments. Rigid motions preserve measures of angles. But when we do dilations, we aren't preserving the lengths. We're just preserving the angles. Okay, so first one. You're going to have your classwork out in front of you. If I look, there are 6 exercises to begin with, and then 3 more. So I'm actually uploading my completed classwork to Google Classroom for you to look at. I don't necessarily need you to complete all of these classwork exercises. Let's see, exercises, yeah, there's 9 of them total. So I don't need you to complete them, but I do need you to be able to apply them to the problem set. And when you get to the problem set, I'd be happy to sit down and explain how we constructed everything. Okay, a lot of this is review. It's review of what we've done in the past, just applying it in a different way. So let's see if we can go through it. First of all, exercises 1 through 6. So number 1, this one says find the center and the angle of rotation that takes segment AB to segment A prime B prime. And then find the image P prime of point P under this rotation. So first of all, I needed to find the center. So I connected A and A prime and B prime. I connected them. Then I found the perpendicular bisectors of B prime B and A prime A, and where they met is the center, O. So I connected A prime and A, B prime and B, and I found the perpendicular bisectors. Where they connected is O. Then I erased everything. So I erased everything and I just connected my center O to A and A prime. I could have connected it to, let's see if I can get a smaller marker in here. B and B prime. I could have connected it that way. It doesn't matter. So this right here says measure angle A prime OA or angle B prime OB. And I got 63 degrees. Okay? Now I needed to construct that. So if we look over here on the next picture, I got 63 degrees right here. I needed to find P prime by measuring 63 degrees counterclockwise. So I drew a line from P. Let's erase this. I drew a line from P to O. Then I got out my handy dandy protractor and drew a long line where I knew P prime was going to be somewhere on that line. Then I got my compass out, I measured pointy end here, I measured a circle. Beautiful circle. And I knew P prime was somewhere on that circle, so it's where 63 degrees and my circle meet. And I found P prime using a protractor and a compass. Okay, number 2. In the diagram below, triangle B prime, C prime, D prime is the image of triangle BCD after rotation about a point A. We have to find that point A. What are the coordinates of A, and what is the degree measure of the rotation? Okay, we don't know what that is yet, but we do know how to find A. First, you can find A by constructing perpendicular bisectors of B, B prime, segment D, D prime, or segment C, C prime. Pick any two, doesn't matter which ones. I drew D, D prime, and B, B prime. I found the perpendicular bisectors, and they met at A. Okay? Then I erased everything, right? I then drew a line from B prime through A to B. I could have done D prime to A to D, and I could have even, C isn't on here very well, I could have gone for C, C prime through A. Okay, you just have to pick one angle. I'll stick with the one I did. And I got my handy dandy little protractor and I measured 59 degrees. Okay, and that's it. We were done. That's all we had to do for that one. The book got 60 degrees. I think 59 degrees is pretty darn close. Okay, number 3, find the line of reflection for the reflection that takes point A to point A prime, and then find the image P prime under this reflection. So first of all, I didn't explain this one very well, so let's explain it now. I drew a line from A to A prime. Then I found the perpendicular bisectors, okay, using my compass. That looks awesome. Let's try again. I drew a line from A prime to A. Then I put the pointy end of the compass here, and I drew an arc and an arc, pointy end there, arc and arc, and I drew my perpendicular bisector. So this means that point A is equidistant from the line of reflection, and point A prime is equidistant from the line of reflection. So now I have to find point P over here somewhere. Okay? So what I actually did, you can ignore this circle here, I didn't use it, but if you put your pointy end of your compass there, pointy end here, you can draw a little arc through here. Then you put your pointy end here and draw a little arc, the distance of P, and ta-da, you get P prime. Okay, it's equidistance from these two arcs, and it's pretty easy once you have those to find P prime. So now we know that this distance is equal to that distance, just like this one is equal to that one. Okay, number 4. Quinn tells you that the vertices of the image of the quadrilateral CDEF reflected over the line representing the equation, so this line right here is y equals -3/2 x plus 2, are the following. So here's the vertices of the image. Do you agree or disagree with Quinn? Explain. Well, I went ahead and plotted all of these points. And the segment made by F to F prime, C to C prime, E to E prime, and D to D prime, they're supposed to be perpendicular to this line of reflection. So if this is my line of reflection, each one of these is supposed to be perpendicular. They obviously aren't. So that was my first clue as to why it didn't actually work. Okay, just obviously those are not perpendicular. So I'm going to erase all those because I drew perpendicular marks and that's not true. So that would be my first clue as to why they aren't. So I disagree because with a reflection, the image point lies along a line through the pre-image point that's perpendicular to the line of reflection. Okay? But I'm going to do this a different way. So this would be method 1. Let's try method 2. Okay? You're going to have to follow along with me here. I'm going to do a little bit of work. If this line right here is y equals negative 3/2 x plus 2, I know that a point through C to C prime will be perpendicular to this line of reflection. So we know things about perpendicular lines and slopes that we learned in Algebra 1. If this slope is negative 3/2 x plus 2, a line perpendicular to this one will have an opposite sign reciprocal slope. So my perpendicular slope is 2/3. If I look at C and just use this perpendicular slope, I can find C prime. So it's going to be, well, sorry, I can find my line, right? So if I start with C and I go -2, -3, this right here is my line. Okay, this line is perpendicular to the line of reflection, and it is the line that C prime should be on. But as you can see, I've plotted C prime, and it's not on that line, correct? C prime should be on that line, but it is not. That is another reason that that those points given to us, the image, are not a reflection of the image C, D, E, F. Okay. Okay. Number 5. A translation takes A to A prime. Find the image P prime and the pre-image P double prime of point P under this translation. Find a vector that describes a translation. So the first thing I did, I used my set square to draw a line parallel to AA prime through P. Okay, and we're looking for the image P prime and the pre-image P double prime, right? So you'll see right here, after I drew that parallel line, I found the distance from A to A prime and made a mark, and that's P prime. Then I made a mark over here, and that's P double prime. That one was pretty fun. Number 6. The point C prime is the image of point C under a translation of the plane along a vector. So first we're going to do is find the coordinates of C if the vector used for the translation is ray BA. So ray BA starts at B and goes to A. Okay, that should actually be just a little bit shorter. Now it should be straighter, but we did our best. So that line is encompassed by, that ray is encompassed by a line, and that line has a slope of -1, -3, or +1/3. Now we can use that same information, except we want to figure out where C is, okay, where the pre-image is. So I'm going to use this in a backwards way and go backwards 3 and up 1. And that right there is where C is, because it went from C to C prime. So C is at a point of 1, 6. Now find the coordinates of C if the vector used for the translation is AB. AB is going to go in this direction. That means we're going to 1, 2, 3 go in that direction. So C double prime, well no, it should still be C, sorry, it's the pre-image, would be at -5, 1, 2, 3, 4, +4. Pretty okay. And you'll see my drawings here. All right, number 7, a dilation with center O and a scale factor R takes A to A prime and B to B prime. Find the center O and estimate the scale factor R. So remember, this is a dilation. Okay, we haven't done a dilation yet today. So I drew through those points and through those points, and where they intersect is O. Okay, that's what we do to find our center. And then I just used my compass. One of my students will be very happy. I used my compass just to measure from here to there, which also is the measurement from here to there. So that gave me, these segments are congruent. I did the same thing. I readjusted my compass and measured from here to there, which is also the same measurement from here to there. So because I did that twice, my scale factor is in fact 2. And here you see me actually doing the work. Okay, I drew lines through here, and then I measured, and I measured again, and I found those are equal. And then I did the same thing for A and A prime, and found that those two segments are equal. Okay, number 8. Given a center O and a scale factor R and points A and B, find the points A prime. So A prime, which is a dilation with center R, a scale factor, dilation, center O, scale factor R of A. So A dilates to A prime. Here I have B prime equals a dilation, center O, scale factor of R of B. So B dilates to B prime. Compare AB with length A prime B prime by division. In other words, find your scale factor. How does this number compare to R? It should be the same, right? Alright, so our scale factor here is 3. So I drew a line through here and there. I used my compass, just measured the distance here and did it 2 more times, which you'll see. So these segments are all equal. These segments are all equal, and I found A prime and B prime. Let's go to the next page. Okay, we draw a line through A, B, and a line through A prime, B prime. I measured them. I got 2 centimeters for AB and 6 centimeters for A prime, B prime. So 6 over 2 is in fact 3, which does match my scale factor. Okay, last one. Given a center of O, a scale factor of R, and points A, B, C, find the new points. Okay, we're dilating. Find our new points. Compare the measure of angle ABC with the measure of angle A prime, B prime, C prime, and what did you find? So first we needed to draw a ray through our center and our point. As you can tell, I did not make C long enough or B long enough. So once I drew the rays, I took my compass and I measured, okay, the length of this, and I tripled it. 1, 2, 3, 1, 2, 3, and 1, 2, 3. So if you look, these are equal. Okay, these are equal, and these are equal. So I can connect. That's A prime. This would be B prime and C prime. I can connect these points. Prime, prime, prime. I'm going to measure, actually this angle was measured for us, 60 degrees, so I just measured this one. I got 61, which I think is darn good. That is okay with some error. And that was totally easy and totally fun. There's our dilation. So lesson summary, there are 2 major classes of transformations. Rigid, distance preserving, and those are not dilations. So we have Distance preserving, which is translation, reflection, and rotation, which we practiced again today, and those that are not, dilations, which we practiced again today too. Like rigid motions, dilations involve a rule assignment for each point. That would be our function notation that we learned again. And also have inverse functions that return each dilated point back to itself. Okay, so all done for today.